Hello everyone. In this problem, there is a gas reaction. A gas A and B react to form gas C. And we don't know the coefficient B. It starts from gas A of 4 times W gram. And the volume of gas A initially is V liter. It reacts with gas B, and the mass of gas B is 4.8 gram. After the reaction, B and C remain. That means A is all consumed, so A is limiting in the first reaction, and the mass of gas B left over is 8 times W gram, and the total volume of the gas is 3 times V liter. As A is limiting, and they introduced a more of gas A with the mass of W gram. After the second reaction, still B and C remain in the cylinder. So A is still limiting. All of gas A is consumed, and the mass of C after the second reaction is 5 gram. And the volume of the gas after the second reaction is the same after the first reaction, 3 times V liter. So in the case of gas reaction, I like to think that the gas on the reactant side are diatomic molecules, so that I don't have to split the atom to make the new molecule. So let's say A is made of 2 atoms of P, and gas B is made of 2 atoms of Q. In such case, C will be made of 1 atom P and B atoms of Q. So initially, the number of moles in gas A molecule is 4W over 2 times atomic weight of P. And the number of moles in gas B molecule is 4.8 gram divided by 2 times atomic weight of Q. So we can simplify each expression. And the leftover after the reaction is 8 times W gram. In terms of moles, that's divided by 2 times atomic weight of Q. That comes from 2.4 over NQ minus B times the amount of mole of gas A molecule consumed according to the coefficient. So the amount of mole in gas A molecule is 2W of this one over MP. And number of gas C molecule produced is 2 times the number of A molecules consumed in the reaction. So that means 2 times gas A molecule is the number of moles of gas C molecule. That's 4 times W over MP. And in the case of gas reaction, if the temperature and pressure is constant, volumes are proportional to the number of moles. So when gas V liter of gas A is consumed, 2 times volume of gas C is produced. So that means in the second cylinder, out of 3 times V liter, 2 times V liter is occupied by gas C molecule, and gas B will have the rest of V liter. So this means the volume of gas B left over is the same as the volume of gas A participating in the reaction. So this leftover in B is the same as initial amount in gas A molecule. So that's equal to 2W over MP. And so And for the second reaction, the amount of gas A introduced is 1/4 of the gas A molecules are present, initially present. So that means the number of moles in gas A is W over 2 times atomic weight of P. So the amount of leftover in gas in B after the second reaction, so this is first and second. From this, B times the amount of gas A introduced. If we subtract this, that's the leftover after the second reaction. And for a gas molecule, to this, add the 2 times a number of gas molecule consumed. That's equal to uh, 5 times W over atomic weight of P. And in terms of volume, because 1/4 of gas A molecules were introduced, 1/4 of this volume will be added to C. So after the second reaction, the volume of C will increase to 2.5 times per liter. And that means the amount of leftover in gas B molecule is 0.5 times per liter. So we can make the second equation, this left over is half times this. So half of this is W over MP. So if we solve this proportion, MQ is 2 times MP. And for the second equation, after cancel this W and MP, two minus B over 2 is equal to 1. That means the coefficient B is 2. So if we change the coefficient B to number 2, and MQ to 2 times MP, this equation changes to 1.2 over MP minus 4 times W over MP. That's equal to 2 times W over MP. So after cancelling MP, 6W is 1.2. So the value of W is 1/5. So finally, the value we want to find is W over B times a molecular weight of B, which is 2 times MQ, and the molecular weight of A, 2 times MP. So W is 1/5 and B is 2, and MQ is 2 times MP. So the final answer is 1/5. So the right choice is number 2, second choice. That's it for this video, and thanks for watching.